Talk about hurricanes. So, in the previous lecture, we talked a little bit about tropical weather. I talked about tropical waves real quick. Those are upward kinks in the streamlines. And then I talked about how, if the conditions are right, they can develop into tropical cyclones. And I mentioned briefly the different stages. We're going to talk a little bit more about that right now. But first, let's actually talk about what a hurricane is. So, the goals for today's lecture are first to understand the key ingredients for hurricane formation. So if I was making a recipe for a hurricane, what would I want? Then we're going to talk a little bit about the anatomy inside the hurricane, and then we're going to talk about the difference between a hurricane watch and a hurricane warning. And that might be useful to you if in the next time you go down to the Gulf of Mexico for summer vacation, or the next time you're in the Bahamas, or and actually very similarly, similar advisories are issued in the Western Pacific. So if you are in East Asia or the Philippines or Japan, this will still have some use for you. All right, so let's jump in and talk about it. So first off, hurricanes are the single largest extreme weather event. And what I mean by that is that hurricanes, unlike tornadoes, which only span a few miles at most, thunderstorms span maybe several miles or several tens of miles, so 10, 20, 30 miles. Hurricanes can span as much as 1,000 miles from end to end. And in fact, if you take a look at Super Typhoon Tip, which is one of the strongest typhoons in the world, we'll talk more about the difference between hurricanes and typhoons later. It actually covered or it could cover, hypothetically, cover much of the western United States. So these can be very large. Not all of them get that big, but these can be very large. Here in the northern hemisphere, and I'm going to talk particularly about the Atlantic Ocean, because those are the ones that we here in the United States are most concerned about. They typically occur from June to November, and we call that hurricane season. These hurricanes are gigantic heat engines. They need a lot of heat. And this actually makes them a little useful as a heat transfer mechanism. And in fact, I'll show you in a little bit, but hurricanes typically start near the equator, and they begin to travel towards the they begin to travel towards the west, and then they will actually curve up into the north. And I'll show you some common hurricane tracks in a little bit. Hurricanes' key ingredient: warm ocean temperatures. Anything above 78 degrees Fahrenheit is considered prime for a hurricane to develop. The other thing that hurricanes need is low upper level wind shear. Now, we talked about wind shear in the last module when we talked about severe thunderstorm formation, and I basically said that wind shear is the change in direction and speed of the wind with height. That's really good for a thunderstorm, a single thunderstorm to form. The problem, however, for a hurricane is hurricanes are so large that in order for them to continue to maintain that size, they need to be vertically built. Well, when you have wind shear essentially shaves at the top off the storm, kind of like a buzzsaw almost. And so when we have higher levels of wind shear or higher values of wind shear, that can actually wreak havoc on a hurricane by shearing off the top of the hurricane. One of the other things that I'll mention again in a future lecture is hurricanes actually go by different names. Typhoons, cyclones. So there really isn't a difference between them. In the next lecture, we'll actually talk about where they're called typhoons, where they're called cyclones. I mentioned that briefly here, but we'll actually talk about where they're called those things. So the last lecture, I ended by talking about different stages of tropical cyclones, and I kind of left you hanging there. But now let's actually talk about this a little bit. So I mentioned that we start with a tropical wave, just that kink in the streamlines, and if there's enough of that hot water, and if there is enough, or if there's favorable low levels of wind shear, so it's not a lot of wind shear, those storms can begin to organize. Once they become organized into a cyclonic motion, they become what we call tropical depressions. And these represent weak, warm chord centers of low pressure. And I say warm chord because typically surface low pressures are cold chord. Here in the mid-latitudes, they're usually cold chord. But in the case of a tropical cyclone, they're warm core. And that means that there's a lot of heat in the center. And these tropical depressions have wind speeds below 39 miles per hour. All hurricanes start out as tropical depressions. Now, as the tropical depression sits over that warm ocean waters, and if there's no wind shear, and if everything's going well, the storm will continue to feed, and it'll continue to grow, and it'll get better organized. Eventually, it will develop so well, to mature so well, that those wind speeds rise above 39 miles per hour. Once that happens, the storm is upgraded to what we call a tropical storm. This is actually where the storm gets its name. So if you think about Hurricane Irma or Hurricane Katrina or Hurricane Ivan, well, that name actually gets assigned to the storm once it reaches tropical storm status. And once the storm has that name, that's its name for the rest of its life. Before that, the storm is usually given a number. So once it becomes a tropical storm, now this is just a warm chord center of low pressure, but now it's becoming more intense. The center of low pressure is becoming lower and lower in pressure. So it's becoming deeper and deeper. The pressure is lowering more and more. And the wind speeds are increasing. And wind speeds for tropical storms range between 39 and 73 miles per hour. Now, if that tropical storm continues to feed, continues to grow, continues to get more organized, if it stays in that favorable environment, it will eventually become a hurricane. And hurricanes represent sort of the top of the list. And hurricanes are very intense, very deep low pressure systems with maximum wind speeds above 74 miles per hour. And as I mentioned, there are other names for it, so we'll talk about those in a little bit. I've even heard the name Willy Willy used for them. But again, we'll talk about that in a few minutes. So this image right here actually shows different tropical cyclones in different stages of development. Right here on the left end of this image, we have two tropical storms that have some organization to them. They're beginning to kind of get that comma-like look to them, so there's definitely cyclonic action there. But they don't look really well organized. However, if you look at Hurricane Iris and Hurricane Umberto over here, these storms have almost a buzzsaw-like look to them. They're much stronger, they're rotating much faster, the center of low pressure is much deeper. And then over here to their east, on the right end of our image, this is a developing tropical depression. And again, this is just a low pressure center that's kind of getting its act together. But the stronger the stronger the storm becomes, the more organized it's going to look. Now, if we actually look inside a hurricane, we can actually pick out a few key components. There are three components I want you to know about: the rain bands, the eye wall, and the eye itself. So rain bands are these areas of strong thunderstorm activity that wrap around the hurricane, and they actually spiral into the center of the hurricane. So they're wrapping around and they're spiraling into the center of the hurricane. This is where you're getting lots of intense rainfall. As you get closer to the center of the hurricane, the winds are becoming stronger. But yes, this is where a lot of the rain falls. Now, as you get closer and closer to the center of the hurricane, these rain bands become more intense, the rain becomes a lot heavier, and the winds become a lot stronger. Eventually, you enter a region, as you're heading towards the center of the hurricane, called the eye wall. The eye wall actually represents the area of the strongest winds and the heaviest rain. This convection actually wraps around the eye itself. And so this is where the strongest winds and the heaviest rain are. So this is where the most destruction in the storm happens. Not so much in those outer rain bands, but in that center eye wall. What's interesting though is that once you go through the eye wall and you end up in the eye of the hurricane, the eye is actually eerily calm. When people hear phrases like the eye of the storm, they're usually thinking about something that's really intense. But in all honesty, the eye of a hurricane is actually very calm. The one thing, though, about the eye of a hurricane is that the pressure is extremely low. And I can actually demonstrate that on this image right here. So, again, if we take a look at a cross-section of a hurricane, so down here's the surface of the Earth, up here's the tropopause, and basically the hurricane itself from the surface of the Earth up to the tropopause almost entirely covers the troposphere. So these are very, very tall convective storms. And when you're in the outer rain bands, you're getting rain, you're getting heavy winds, but it's not too bad. But the closer you get to the center of the storm, the winds become more and more intense. And you can actually notice that on this blue line right here, which represents wind speed. As you begin to approach the center, the winds begin to increase in intensity. And the reason why is because the biggest change in pressure is located right here along the eye wall. Once you reach the eye wall, wind speeds top out. And then once you get into the eye, wind speeds suddenly decrease. And then once the eye passes, you get into the other side of the eye wall, wind speeds increase again. Now with that said, one of the very common misconceptions that people who are dealing with a hurricane have is they see the eye pass over, the sky clears, the winds calm down, and they think to themselves, yay, the storm is over. They go outside, they start to clean up, they start to get things fixed up, and they try to begin to move on with their life. Well, that's a big mistake. About 10 to 15 minutes later, the eye passes, and now you're in the other side of the eye wall. So if you're ever stuck in a hurricane, and you're trying to figure out, okay, am I in the eye of the hurricane, or has the storm passed? Pull out a barometer and look at the pressure. If you recall from a few modules ago, the average surface pressure here on Earth, here at sea level, is 1,013.25 millibars. So look at a barometer and see if you see something like that. If it's close to 1,012, then you know that the hurricane has passed you. If it's down, say 980, 970, 960, so it's much lower than 1,013, then you're in the eye of the hurricane. And if you're using inches of mercury, the average inches of mercury, the average sea level pressure in inches of mercury is 29.92 inches of mercury. So if you notice anything substantially lower than that, so 28 point something or 29.00, so something really low like that, you're in the eye of the hurricane. But if it's closer to 29.92, then the storm has passed. So that's how you can tell, okay, I'm in the eye of the hurricane, or no, I'm not, the storm has passed. And just a little personal note here, it's actually an item on my bucket list to experience the eye of a hurricane. And you better believe if and when that happens, I will be standing in there holding up a barometer and nerding out. So I wanted to talk a little bit also about the anatomy of a hurricane. This is very similar to tornadoes as far as wind speed is concerned. When calculating the wind speed of a hurricane, you have to take two things into account. First, you have to take the speed of the hurricane's rotation, so that's usually what we call the maximum sustained wind speed. You need to take that into account, but you also need to take into account the hurricane's forward motion. Where the two add up is where the two are going in the same direction. So on this side of the hurricane, over here, so this is a hurricane heading north at 70 miles per hour with a maximum sustained wind speed of 115 miles per hour. Well, right here, where the wind is blowing in the same direction that the hurricane is traveling in, you add them. So 115 plus 107 or plus 70, this region over here is experiencing winds of 185 miles per hour. So that's very intense. On the other hand, if you're on the other side of the storm, now the winds are blowing in the opposite direction of the hurricane's forward motion. You subtract 70 miles per hour. So here, winds are only 45 miles per hour. So that makes a big difference between a blustery day and your house being destroyed. And so very similar to just like tornadoes. And as meteorologists, we always call this area here in the front of the storm the right front quadrant. So it's this right front quadrant, so on the right and the front of the storm, that ends up actually being the most intense. That's where the wind speeds are the strongest. Any of the other locations aren't as bad. So when do hurricanes most commonly occur? Well, I mentioned earlier in the lecture that hurricane season, at least here in the Atlantic and Pacific Ocean, and Eastern Pacific Ocean, so here in the United States, hurricane season is typically June 1st to the end of November. And usually when hurricane season starts, conditions aren't quite there yet for hurricane formation to occur. So hurricane occurrence is still relatively low during that time. However, if you notice, as we get into the months of July and August, the number of hurricanes that actually occurs becomes greater and greater. And it usually peaks around the second week of September, usually around September 10th. That represents the peak of hurricane season. So usually most hurricanes, if you think about Harvey, Maria, and Irma, those all happened in late August, early September. That's usually the peak of hurricane season. And then once you get past September 10th, hurricanes begin to become less common. There's usually a secondary peak in October, and there's been a lot of research trying to figure out why that happens. I'm not going to speculate here. I've got some ideas, but I'm not going to speculate here. And then very quickly, hurricane occurrence quickly declines as soon as you get into early November. And then by the time you're in December, it's almost completely gone. Hurricanes can actually occur outside of this time period. But for the most part, this is when they occur. So I mentioned at the beginning of this lecture that hurricanes typically take an east to west track. And that's usually because when they form, they're forming along the trade winds. They're forming along the ITCZ, and the ITCZ is carrying them from east to west. Now, what actually happens, though, is as these hurricanes are traveling to the west, they begin to feel the effects of mid-latitude high pressures. If you recall, and I'll draw these up here. If you recall, here in the middle of the Atlantic, according to our three-cell model, sorry, I always have a hard time following this cursor. Here in the Atlantic, there is a high-pressure system. And if you remember, high-pressure systems rotate clockwise. Sorry for the terrible penmanship there. And then here in the Pacific, you see the same thing. There's a high-pressure system in the center of the Pacific that is rotating clockwise. Well, what actually happens is, As you get to the edge of the ocean basin, usually these storms will actually ride along this high pressure system and they'll ride up and around it. And so hurricanes that are traveling from east to west, as they reach the edge of the Atlantic, so over here near the east coast of the United States, they begin to take a turn up and then out to the west as they begin to get caught up in the mid-latitude westerlies. Now, what does that actually mean for us here in America? Well, that means two very interesting and scary things. If this didn't happen, if hurricanes only followed the trade winds, most hurricanes would stay south of the United States. You'd still get some that develop in the Gulf of Mexico, but for the most part, they would mostly stay south of the United States. Unfortunately, because of these mid-latitude high-pressure systems, they begin to take a northerly turn. So then they get up close to the east coast of the United States and sometimes can graze the east coast of the United States. And many hurricanes in the past have done that. Hurricane Hugo, Hurricane Fran of 1996, that was a long time ago, ancient history now. But Hurricane Sandy originally started taking a path like that. And you'll learn more about Sandy during this week's module activity. But each of these hurricanes was taking a west to, or an east to west track and then made that northerly turn. Other hurricanes such as Harvey or even Katrina did the same thing, but now in the Gulf of Mexico. The good news is, for us here on the West Coast, hurricanes usually don't travel our way. They usually travel out to sea and then maybe begin to turn to the north. And by this point, they're long away from us. Every so often, a hurricane will make it up this way. But if you've ever wondered why we don't have hurricanes, it's because the waters here are just too cold. Cold water kills hurricanes. Now, once a storm becomes a hurricane, there's a big difference between a weak hurricane with winds of 74 miles per hour and a stronger hurricane with much higher winds. And we want to be able to differentiate one storm from another. So we actually use a scale called the Saffir-Simpson scale, developed by two scientists named Saffir and Simpson, who ranked hurricanes on a scale of 1 to 5 based on their maximum wind speeds. Now, this is a little bit different from a tornado because tornadoes are ranked based on the damage they cause. Hurricanes are actually ranked based on their wind speed. So this is more of a potential damage type of thing. Hurricanes that are relatively weak have wind speeds of 74 to 95 miles per hour. These are Category 1 hurricanes, and the damage they cause is relatively minimal. On the other hand, as the hurricane gets stronger, if it reaches Category 2 status, it has wind speeds of 96 to 110 miles per hour. That creates moderate damage. There you can start to see shingles blowing off of roofs, trash cans can get picked up in that. You could start to see some noticeable damage. Anything Category 3 and above, is what we call a major hurricane. These are the kind of hurricanes that can cause extensive and catastrophic damage to them. A Category 3 hurricane can cause massive storm surge. 4 is even worse, 5 is even worse. And in fact, there's actually some cool videos that I can show that demonstrate the difference between a 1, 2, 3, 4, and 5. But Category 1 and 2 hurricanes, typically if one of those is bearing down on you, officials will usually tell you, you know what, board up your windows, batten down the hatches, make sure you have plenty of booze, water to drink, make sure that you have all of your provisions and libations and stuff like that taken care of. Not that I'm promoting that, but make sure that you have all that stuff taken care of and just ride it out. You're gonna be okay. On the other hand, Category 3, Category 4, or Category 5 storms, those are the kind of storms where it's like, no, you need to get out of Dodge. You need to evacuate. So you actually usually see large-scale evacuations issued for Categories 3, 4, and 5. For a 1 and 2, again, they want you to get away from the coastline. So if you're like right on the coastline, you may want to move in a few miles. But other than that, just board up your house and ride it out. 3s, 4s, and 5s, no, you need to get out. Like there's nowhere safe. With that said, I just mentioned that in the case that a hurricane is bearing down on you, you may be hearing from different officials what you may need to do. Well, here in the United States, we have a series of hurricane advisories we issue, and these are actually internationally recognized and are issued by federal governments. Here in the United States, the National Hurricane Center issues these advisories. And there are two types of advisories, two types of products that they issue. The first type of product that they'll issue is what's called a watch. A hurricane watch simply means that a storm, whether it's a tropical storm or a hurricane, may potentially affect your area within 24 to 48 hours. What this means is there's a storm on its way. We're not totally sure if it's going to hit you yet, but start preparing. Start preparing. This is when you want to go to the grocery store, get your bread and milk. This is when you want to prepare. You want to start boarding up your house. You want to start planning for it. However, it might not happen. On the other hand, if a storm is expected to affect your area, meaning that we're pretty confident it's going to hit your area within the next 24 hours, they will upgrade that watch to what's called a warning. And these are issued for both tropical storms and hurricanes. So if they think a tropical storm is going to hit your area, they'll say a tropical storm warning is in effect. Or if a hurricane is going to hit your area, they'll say a hurricane warning is in effect. And in this case, the storm is expected to hit your area in the next 24 hours. Here is an image, and this was from a tropical storm from many years ago, Tropical Storm Hermine, that was predicted to hit this region right here. And so this region is, get my cursor to work here, this region here is the Texas Gulf Coast as well as northern Mexico. And so this region was expected to be impacted by Tropical Storm Hermine. And what they issued was a tropical storm warning for this whole region, basically saying, hey, in the next 24 hours, you are going to experience tropical storm conditions. Now, one of the things was the storm was still over warm ocean waters. So it still had fuel to continue to grow. We can't necessarily predict how much these things are going to grow. And sometimes they catch us off guard by how rapidly they grow in intensity. It was possible that this storm could develop into a hurricane. And so what they actually did was, in this region right here, if you notice there's a little shading of pink overlying the blue shading. This region here, they also subsequently issued a hurricane watch, basically saying, okay, this thing is currently a tropical storm. We know you're going to get tropical storm conditions, but it could develop into a hurricane. Plan for that. Be on the lookout for that. Just expect it to happen. That doesn't mean it's going to happen, but plan for it. And so they issued this hurricane watch for this region right here. Just a little bit more about this map. This map actually is showing us three important things in addition to the position of the storm. It's showing us those advisories. It's showing us the projected path of the storm. So it's expected that, okay, the storm is currently here. It's expected that the storm will take a path like this. However, hurricane predictions are very uncertain. And so this white shading area is what's called the cone of uncertainty. And in this cone of uncertainty, the center of the storm could travel anywhere in this cone of uncertainty. Usually, the shorter term the forecast, the smaller the cone of uncertainty. So this is 10 a.m. Monday morning. By 7 a.m. Tuesday, so the next day, the cone of uncertainty is still relatively narrow. But notice that as you go from 7 a.m. Tuesday to 7 a.m. Wednesday, and then from 7 a.m. Wednesday to 7 a.m. Thursday, the cone becomes wider and wider. That's because the further out in time you go, the more uncertain the forecast is. We'll actually talk about why that is in a few weeks when we do Module 11. But we'll talk about that then. So for the next lecture, I'm going to talk a little bit about the hazards that hurricanes pose, and then we're going to talk a little bit about what's in a name. So until then,